Question number 1.1 on the board. A motorboat going downstream overcame a raft at a point A. Tau minutes later, it turned back and after some time passed the raft at a distance L from the point A. Find the flow velocity assuming the duty of the engine to be constant. For these kind of problems, it's best to start with a diagram always. So let's say this is the river, okay, and the river has some flow velocity. Let's call that Vf. And then there's a raft. So a raft is something that flows along the river and it has no velocity of its own, so it assumes the velocity of the river. Okay, so let's say this raft was at point A. Okay, when the motorboat crosses. So let's say the motorboat has its own velocity with respect to ground Vm. So there is some relative velocity going on here. So downstream, its total velocity will be velocity of motorboat plus the flow velocity. Okay. So what the question says is this motorboat went downstream after tau minutes later. So maybe it reached a point C. Okay. After tau minutes later, it turns back, and after some time, it doesn't say how much time. After some time, it meets the raft, which is in that time interval tau plus t, has reached from A to B. Okay, and it's given that this distance AB is L. Okay, we don't know this distance, so let's assume this distance to be x. Okay. Now a diagram always helps. So now that we have that on the board, let's break this down. So I will say we'll take the case of motorboat. And we will take the case of raft separately. Okay. So motorboat on its journey from A to C. A to C. Okay, what happens? So there are a few things. What's the total distance? So total distance is L plus x. Its relative velocity is Vm plus Vf, the flow velocity, and time it took to make that journey, it's given as tau. Okay. Now from C to B, again let's write down the distance. I'm just breaking this down so you can understand it better. The distance covered is x. Its relative velocity, now it is Vm minus Vf. Why? Because from C to B, the motorboat's velocity is this way. So its effective, the relative velocity is Vm minus Vf. So we can write Vm minus Vf. And let's assume the time taken in this journey is t. Let's look at the case of the raft. The raft makes only the journey from A to B. Okay. What's the distance? The distance covered is L. What's the relative velocity? Raft doesn't have any velocity of its own. It assumes the velocity of the river, so which is Vf, and the time taken this time for raft to come from A to B is tau plus t. Okay. Now then let's write down our equations. So for this one, distance L plus x is Vm plus Vf times tau. For this one, x is equal to Vm minus Vf times t. And for this one, L is equal to Vf times tau plus t. Now our goal is to find flow velocity, which is Vf. Vm is constant, so that's fine. I mean, so our goal is to find Vf. T is unknown, x is unknown, Vm is unknown. Okay, let's do this. Let's subtract. So these are three equations. Let's subtract 2 from 1. So we get L is equal to Vm plus Vf times tau minus Vm minus Vf times t. And then let's substitute the value of t from 3. So what is the value of t from equation 3? It is t is equal to L by Vf minus tau. So let's substitute that here. So this is Vm plus Vf times tau minus Vm minus Vf times t, and t is L by Vf minus tau. Let us expand this. Vm tau plus Vf tau minus Vm by Vf L. This times this is minus Vm tau, and this minus becomes plus Vm tau. This times this is minus L. This becomes plus L. And this times this is plus Vf tau, and with this minus, this becomes minus Vf tau. Okay. Now we have Vf tau and minus Vf tau we can cancel out, and we can write L equals 2 Vm tau, 2 Vm tau, this and this, minus Vm by Vf L plus L. Now both these sides L we can cancel out, bring this term to the other side. Vm by Vf L is 2 Vm tau. We can cancel out Vm, so flow velocity, which is what we have to find, is L by 2 tau is the answer. Okay, I have not substituted the values. You can substitute the values and get the answer. Cheers.